With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, let's start the question. Arrange the following in order of their pKb value. So, pKb value is related to the basicity, yes, basicity of a particular compound, yeah. So, we have been given 3 different bases out here, yes. The first one is a kind of, what you could say, a guanidine kind of a derivative, yes, okay. And the second one is obviously a simple aliphatic amine, okay. And the third one, as you can see, is an imidine, okay, right. Because we are having 2 NH groups, and that is the reason I'm calling it as imidine, yes. So what we are going to do is we have to arrange them according, or otherwise we have to watch out for the basicities and accordingly arrange them, yes. So pKb, what does it indicate? It's negative logarithm of log kb, yes. Now what is kb? Kb is the dissociation constant of a base, yeah. So what's the relation of this particular kb value or pkb value with basicity, okay. So when we say that a particular compound has a particular pKb value, or otherwise 3 compounds over here, if I say that they have some respective pKb values, then we can relate pKb and basicity in the following way. So as I told you, it's negative logarithm of kb. Kb means the dissociation constant, as I told you earlier also, yes, dissociation constant of a base, yes. So that itself means that if it has a very large value, okay, it means it's a perfect dissociation or very good dissociation, indicating a strong base, okay. Now since pKb is negative logarithm of kb, definitely it means that a higher pKb will always indicate a weak base, okay, and the vice versa will be true. That means a smaller pKb value or a lower pKb value will indicate a strong base. Got the point? Yes. Now the pKb, kb and the basicity basics are clear. Yes, the concept is clear. So now what we have to do, as suggested, we have to arrange it in order of their pKb value. Okay, so the lowest is going to be the most basic, okay, and accordingly we have to arrange. Now let us look at these bases over here. What do you mean by a base, guys? A base means that a good base will always be a very good donor of electrons, isn't it? Yes. So the nitrogen present in these 3 bases should be able to give away their lone pair of electrons very easily to any other species, yes. So making these making these electrons available for donation is related to their structural hindrances, yes. Lesser the structural hindrance, more would be the availability for the donation part, yeah. Now let us look at the very first one, okay. The first one, as you can see, is a guanidine type, as I told you, okay. Let me just draw the structure. So here you have the structure as follows. So there's a nitrogen, NH, and then we have one more ring over here, and we have one more ring over here also, I guess, right? No, okay. So these 2 are the rings present, and in this case, definitely we can look out for a resonating structure of this particular structure, isn't it? So these 3 atoms, that is nitrogen, carbon and NH part, would undergo a kind of a rearrangement, a tautomerization, due to which I would be getting a resonating structure as follows. So look for it very carefully. There's going to be a single bond, and then there's a possibility of a double bond N, yeah, and this is it. So this would be one of those resonating structures. Yeah. So obviously a resonating structure itself means that definitely in that case you would be having more and more stability, yes, being enhanced. Yeah. And the conjugate acid of this particular guanidine type would be more and more resonance stabilized. Yeah. So this definitely is going to be more and more resonance stabilized. Okay, there would be more number of structures. Now what about B? B is a simple aliphatic amine, isn't it? Yes. So when I'm talking about B being a very what I could say simple aliphatic amine and surrounded by two methyl groups over here, you can definitely say that the lone pair over here over nitrogen would be available, okay, very easily as compared to the one which is there in guanidine, because we have certain participation of our nitrogen in this resonance part. Yes. So definitely in that case, B is going to show me a lower pKb value, or otherwise I would say it is going to show the availability of this lone pair of electrons easily. What about imidine? So imidine is having H2N and we have CH and double bond NH. Yes. So again a tautomerization can occur, and what would happen is as follows. So NH, double bond CH and dash NH2. This is what can occur, isn't it? So again a resonance is being held, but this is not a kind of a cyclic formation. This is a very simple aliphatic kind of an imidine molecule, and hence the resonating structure would be as follows. Yeah. Now let us analyze their pKb values. Let us arrange them in their pKb value order. Now when we discuss about their pKb values or their basicity, as you had observed that guanidine is having 3 nitrogen atoms out there. Yes. And in that case their lone pairs which are there are very much available for donation. The double bond over here is definitely going to delocalize from one point to the other one, but then still we do have the availability of the lone pair of electrons from any other 2 nitrogen atoms which are going to stay back. Yes. So in that case we can say that yes, the guanidine, since it contains 2 nitrogen atoms and a whole resonance stabilization structure is there, we can say that it is going to be the most basic of all. Yeah. What about B? B is having just 1 nitrogen, but in comparison to it, C is going to have 2 nitrogen atoms once again. Yes. Definitely there is going to be a kind of a resonance structure being seen over here, but then again we do have the availability of the lone pair of electrons. So just after A, you could say the second most basic is going to be C. Yes. And the least basic of all is going to be B. Yes. So in that case, you can say that the pKb value order is going to be A, C and B. Okay. A being the most basic and B being the least basic. Okay, fine. So definitely we were discussing about the donation of the lone pair of electrons, but this aspect needs to be looked into, wherein your nitrogen atoms, the availability of the lone pair from how many nitrogen atoms is possible also needs to be taken into consideration, and hence we have already discussed that point. Now coming back to which option is going to be correct, then it's going to be, yes, so B would be having the largest pKb value, isn't it? Now, the order which I presented was obviously the basicity order, okay? If at all by mistakenly I must have said that it's pKb. No, it's basicity value order which I have placed over here. So A would be the most basic, then comes in C, then comes in B, which itself means that B would be having the highest pKb value, after which will be C and then A. Yes. So as I told you, it's going to be B first, then C and then A. Hence option number 4 is the correct option. I hope you understood the concept. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.